Good evening, everyone. Welcome to the Carolina Weather Group. This is the Wednesday, July 18th, 2018 edition of our little weather get-together for the week. This is show number 240. Man, we're creeping up on that 250 episode pretty quickly. Tonight we have Roger Edwards. He's one of the lead forecasters out at the Storm Prediction Center in Norman, Oklahoma, and happy to have Roger on with us tonight. We're going to be talking about tropical tornadoes, basically tornadoes that are associated with landfall in tropical systems, either hurricanes or tropical storms. So with us living here in the Southeast, most of us are in that tropic zone where we have to pay attention every summertime, and tornadoes are often associated with landfall in tropical systems. So Roger's going to be going over some information with us tonight, kind of giving us some facts and better how to detect how tornadoes may form from those tropical systems. And first-time guest as well for Roger, so we'll let him introduce himself here in just a little bit. Before we do that, though, this is our live broadcast, and we are streaming on numerous locations: Facebook Live, Periscope, our YouTube page. So if you are watching tonight and you have any questions, the best way to get those to us are via Twitter at Carolina WX Group. You can tweet those to us, and we will look over them and give them to our guests as they fit in during the conversation tonight. And if you're listening on the podcast, we'll let Roger share his Twitter information towards the end of the show. And that way, if you have any questions, you can direct them to him personally. So we're again happy to have Roger on and happy to have you guys viewing us tonight. Before we get into tonight's program, let's quickly go around and bring in the panelists. Let's start off in Texas, where Ashley, I guess you guys are baking in the heat this week, huh?
Yeah, pretty much. Nothing much to report on precipitation or storms or anything like that. We've got high pressure building in, triple digits as far as you can see in the forecast for the next 5 to 7 days. 0 precipitation forecasted by the Weather Prediction Center. So we're just looking at hot, dry, and a really bad potential for fires to break out around here. So we're monitoring all of that for wildfires. But back to you.
That's a good thought, Ashley. I didn't think about the wildfire threat, especially with it being so hot and those firefighters. So hopefully that front stays calm for you guys. Let's go over to the Charleston, South Carolina area. I'll bring in Jared Smith. He can kind of give us an update of what's going on along the coastal areas. And then we'll bring Shay Gibson in to give us our weekly tropical report. So, Jared, how's things there in the Charleston area?
Well, we went from record low precipitable water values to record high precipitable water values. Can I just get something in the middle, please? But alas, so it goes. Contending with some showers and storms tonight. We've been in a bit of an active pattern here. What I'm going to do is I'm going to bring up radar here using AWIPS provided by Allison House. They have started providing AWIPS 2 services to the public, and so if you want to run similar software to what the National Weather Service is running, now you can. So looking at the radar here with the geostationary lightning mapper overlaid, still some pretty good rumblers. I had a really nice little shelf cloud outside my window a little while ago, but this is starting to fall apart a little bit as things calm down. The atmosphere gets whipped over, and all begins to calm down as it does this time of year. Looking at the precipitation amounts from a multi-radar, multi-sensor, MRMS, big jackpot over here between Ondaw and Mount Pleasant, about 2.5 inches roughly, estimated by the radar. Had a little bit of minor flooding in these areas, but nothing too crazy. Shay said he got dumped on over in Wando. I'll let him talk about that. Near Somerville, Goose Creek, Ladson, those areas, about a couple inches of rain as well. So kind of feast or famine, though. Around my place, I got nothing. So I've been getting kind of shafted on this, quite frankly, and I don't appreciate it. But, I'm sure that with the rest of the week being what it is, decent chance for additional showers and storms to fire. And, just going to stay in this active pattern with the trough in the east. So no big deal. It's July in Charleston. It's warm, muggy, and we have afternoon thunderstorms. So that's just the way it is. Back to you, Scotty.
Thank you for that report, Jared. And also with those showers and thunderstorms, we have mosquitoes galore. I know the mosquitoes are bad here in western North Carolina as well. So with that rain coming in, it's not going to help the situation.
Yeah. The St. Bird is very busy.
That's right. That's right. Well, I'll quickly give you an update since James isn't here to cover the North Carolina area. We've had hit and miss showers and thunderstorms throughout the week. I know here at my location, Sunday night and then again Monday night, we picked up close to 3 inches of rain in those 2 nights with scattered storms. So if you do get under one of those storms, you consider yourself lucky, you get some beneficial rainfall, but otherwise it's kind of dry around here. We're watching a change in the pattern towards the weekend into early next week as we get into a more active and rainier pattern, but also cooler as well. So I, for one, like the heat, but I know a lot of people are wanting some cool weather. So hopefully next week, a lot of people will be getting their wishes there. So Shay, I'll give it to you as we look at the tropics real quick, and then we'll get into tonight's topic.
Thank you, Scotty. Yeah, as Jared said, lots of rain here where I live in the Wando area near Allendale. We've had 3+ inches, going on 3.5, and more to come. And that's in the last 21 hours. So we, just like he said, it's hit and miss in some spots. Some people have gotten a trace and other people have gotten dumped on. So hopefully the next couple of days, I think everybody will get a little bit of rain over their areas. So yeah, stay patient, Jared. Let's go ahead and talk about the tropics, and let's go ahead and share screen. I'm going to give everybody a little bit of vote of confidence here and say that no tropical cyclones are expected in the next 5 days. Things are pretty quiet in the tropics. There's lots of Saharan dust aloft across the tropical Atlantic, off of Africa, all the way across the intertropical convergence zone. Very dry, cooler than normal sea surface temperatures as well. There's a lot of inhibitors that are keeping things from really spinning up and developing there. But I do need to say that what we have going on here is what we call an undulating front. This is sort of a stalled cold front that will meander through the southeast region over the next couple of days or so. And what we have is we have blocking high pressure to the north over the Great Lakes. We have Atlantic high pressure, more of a Bermuda high, stretched across the Atlantic, keeping this front pinched in between. And so what this does is it drags moisture along it. You get a little bit of lift out of the Gulf, get a little bit of a trough coming in from the west, and you get a little bit of moisture traveling along that boundary. Now with high pressure to the north, we always have to watch for a little bit of top spin. You see these L's here. These represent areas of low pressure, and these come and go. So most of these don't ever develop into anything, but as soon as they get over the water, even sometimes before they get over the water, you can get a little bit of spin, and that can actually trigger some sort of area of initiation for the National Hurricane Center to sort of put their eyes on. So we're going to be looking for that. You can see the sea surface temperatures are plenty warm out there. Lots of 80s to go around. The Gulf of Mexico on fire pretty much. And if we look at the SST composite from NASA, you can see here, this is the loop from June 28th to present. And the sea surface temperatures are pretty warm. And then you see this swirl, this little cooling area. Well, that's from Hurricane Chris and from subtropical storm Beryl as they went up and through this area and sort of cooled those sea surface temperatures down. But you can see them filling back in as the Gulf Stream rewarms the surface of these waters, and the shelf waters fill back in with the southerly wind. So not quite out of the woods yet with that. And we have plenty of warm waters out there. Again, we showed this on the last show. We're starting to get towards the end of July, and we're going to see sort of an uptick in activity. We are expecting possibly an average to maybe below average season. That doesn't mean that one major hurricane can't change your mind. We're looking at a spike as we go into August, and then things start to peak out around September the 10th. So we're still very far down here on the scale when it comes to where we are in the hurricane season. So that's always something that keeps you kind of humble during the season, as we still are kind of in the younger part of it. And we have to keep watching, especially those areas that I talked about along those cold fronts that stall. So right now we're watching the southeast coast. We're watching the Gulf of Mexico. Just areas to watch. Nothing can concern right now unless you live in these areas where heavy rainfalls and thunderstorms are coming down almost daily. So lots of moisture in the air. And with that, I'll go ahead and go back to Sky to introduce our guest. And speaking of tropical weather, we're going to be talking about tropical tornadoes tonight. But go ahead, Scotty.
Thank you for that, Shay. And as you know, we talked about before the hurricane season, it only takes one storm to kind of wreck everybody's summer. So just be mindful, even though it's really low activity, that doesn't mean that we will not see a hurricane this year. So let's go into our guest tonight. Mr. Roger Edwards joins us again from the Storm Prediction Center in Norman, Oklahoma. So Roger, we were talking before the show. It's pretty hot out in your neck of the woods as well, isn't it?
Well, not today, but it's about to get that way. We've got High temperatures forecast around here around 107 tomorrow, and in the upper 90s to hundreds the rest of the week till that pattern breaks, like you guys were talking about. So we're going to be baking a little bit, but I'm a Texan, so I'm used to it.
There you go. Well, Roger, before we get started into our topic tonight, a lot of our viewers and listeners are kind of weather enthusiasts, but may not know the inner workings of all of the weather industry. So kind of tell us a little bit about yourself, and then what you specifically do there at the Storm Prediction Center, and then maybe what you guys at the Storm Prediction Center do for our country, what you guys, how you forecast.
Oh, sure. Glad to do that. I've been at the Storm Prediction Center, or its predecessor, the National Severe Storms Forecast Center in Kansas City, since April of 1993. In fact, the week before the infamous Catoosa tornado, because I chased that day. And before that, I spent 3 years at the National Hurricane Center in Miami, where they recruited me right out of graduate school, and here at OU, Boomer Center. And then before that, I was at the National Severe Storms Lab for a little over 4 years as an undergrad and grad student, studying tornadoes and going out with Toto and the research teams and the chase teams, and managing the slide and video collection at the lab. And I will say that it's every kid's meteorology fanatic's dream job to be able to get paid to look at tornado slides and videos. So that was a great job. And but while at the Hurricane Center, I worked with some phenomenal people. I do here at SPC. I've always loved tornadoes and hurricanes, and so this research specialty of mine in tropical tornadoes bridges the gap between the two loves, and it allows me to legitimately and officially serve two masters at once.
And that sounds good. And Roger, for those who may not know, like we were talking about, exactly what is your job there at the Storm Prediction Center? How do you guys help the different areas throughout the country? What is your day-to-day operations there?
Well, I'm a lead forecaster at SPC, which basically is a shift oversight role, and we're in charge of all the products that go out of the office. And so we proofread those. Every product goes out with two eyes on it. We have a strong philosophy that way. Minimizes embarrassing typos and glitches, ensures quality. And my role on shift is basically to make sure that things run the way they should and that everything goes out. Our primary focus is on severe weather threats nationwide. Hail, severe thunderstorm winds, and tornadoes, of course. And so we issue severe weather outlooks, which are generalized areas of potential drawn on maps with discussions from day 8 all the way down to day 1, or the current day. So a little more than a week out down to the current day. And then from there, we drill down on what we call the mesoscale, which is basically the size of a small state like South Carolina, or part of a state like Oklahoma or Kansas, where we focus on short fuse threats for severe weather, the next 6 to 9 hours or smaller. And then we issue mesoscale discussions, which are areas of both graphic and text descriptions that focus on the severe weather threat and where we might need to issue watches. And from there, we drill down to the tornado or severe thunderstorm watch itself, which of course is a familiar product to a lot of our audience. In fact, those among us who are over about 40 may remember the broadcast on the weather radio. The National Severe Storms Forecast Center in Kansas City has issued a tornado watch. Well, that was us. And we moved to Norman in 1996. We issue watches in a very similar format as then, except obviously now we've gotten away from the box. We've gone down to the county level on watches. Once the watch goes out, of course, those are cleared and modified by the local forecast office. We do that in conjunction with the local forecast office. It's what we call a collaborative process the whole way, to use bureaucratic jargon. And so it's a really good setup. And then once the watches are out, of course, we issue mesoscale discussions on those. We continue to monitor the weather at all times, 24/7, 365. We work Sundays, holidays, rotating shifts. My family can testify to all the logistical hassles about that. I work a lot of night shifts. I tend to prefer night shifts, but we do rotate our shifts around, like at the local forecast offices in a lot of respects. And so we're here when everybody else is sitting around eating Thanksgiving dinner or shooting off firecrackers on July 4th or out at the lake on Memorial Day or Labor Day. We're here forecasting. And so our job is constant, 24/7. We have a lot of severe weather enthusiasts, a lot of really passionate people here who love what they do and who do scientific research in it. And so we have an enormous number of scientific publications on our website. So it's not just a forecasting, we do research as well. So if you visit our webpage, spc.noaa.gov, you'll see all our forecasts. And if you go to publications, if you're interested in scientific publications, we've got a ton of those as well. We also do fire weather outlooks nationally for the whole country, and that's obviously a bigger and bigger concern the last several years. And so those who are interested in fire weather should certainly check us out as well.
So Roger, you guys have a full plate on any given day. And then as we turn our attention to the summertime, you guys not necessarily are like the Hurricane Center looking out for developing storms, but you keep your eye on it because of kind of what we're talking about tonight. Landfall and tropical systems can create severe weather in some areas.
No, you got it exactly right on that. We coordinate closely with the National Hurricane Center, where I used to work, on tropical cyclones that are threatening to make landfall in the contiguous U.S. So we cover the 48 states from Atlantic to Pacific, and that includes the tornado threat from tropical cyclones. And so as tropical cyclones, or I'll call them TCs sometime for short, hurricanes, tropical depressions, tropical storms, remnant lows, as those affect the U.S. mainland, we jump in on the hurricane hotline and coordination calls with the National Hurricane Center to make sure our forecasts are consistent in terms of the threats. We use the National Hurricane Center's wind radius forecast site, which basically is a proxy for a size forecast for us. We use their track forecast for our outlooks in terms of positioning outlooks with respect to the favorable areas where tornadoes occur in hurricanes and tropical cyclones. And they take our guidance in terms of the tornado threat and insert that into their hurricane statements. So it's a very close relationship. And then as the tropical focal point here at SPC, it's one that I'm really happy and honored to cultivate.
So, quick question for you now: when it comes down to any city USA, especially along the coastline or even portions inland, what you do is what the National Weather Service offices locally put out for their tornado watches and warnings. Correct? I mean, we're talking about if I live in Tampa Bay, Florida, or anywhere along the coast, and we're getting tornado watches and warnings. That's coming from your office first on the guidance, and then the local National Weather Service offices sort of relays that information, or how does that work?
Well, I'll give you an example from Houston, since that's the case that I'm researching right now with Harvey. In that particular case, the tropical cyclone is intensifying rapidly toward Category 4 status as it's about to make landfall around Rockport. The tornado threat, as I'll show later, is typically north through east or east-southeast of the center of circulation in the outer areas more than in the inner areas. And so as this thing is intensifying, as it's moving toward the coast, we're coordinating with the National Hurricane Center, as well as the Houston office and Corpus Christi and other offices in the area like Lake Charles, on where the tornado threat is going to be the most intense. We already have outlooks out that are based on the Hurricane Center's forecast of the size and the track of the storm. And so we have outlooks out for the coast and for some areas inland. And then as it approaches, the threat increases. Hopefully before tornadoes start, before the supercells begin to affect areas inland, we'll issue a tornado watch. And that tornado watch will cover areas, in Harvey's case, from the Texas coastal bend over toward southwest Louisiana, with a specific emphasis on where the threat was greatest and where it turned out to be the biggest, around the Houston area. And in fact, Houston itself was in a tornado watch for 60 hours straight, which, as far as we know, is a record for any city or major metropolitan area, because Harvey was so big and slow moving, wouldn't go away. And it was kind of an extreme example in that regard. Most of these things are in and done within a couple of days. Harvey stayed around a long time. And so in that case, we were issuing the tornado watches. Then as the tornado threat drilled down to the local scale, individual supercells formed within the hurricane envelope and started to tighten up. The Houston office and others affected issued tornado warnings, mostly based on radar signatures, sometimes on reports, because radar doesn't always see tropical tornadoes and supercells well. They tend to be smaller. They tend to be weaker. They tend to come and go faster. And so sometimes we still depend on spotter reports and other reports to issue tornado warnings, and they definitely did for that. Harvey lasted 7 days as a tornado-producing storm. That's another record. So that was kind of an extreme example for us. Another extreme example would be Hurricane Ivan, after it moved on shore around Pensacola in 2004. Produced a record 118 tornadoes in 3 days. And as far as we know, to the best of our known records, that is the largest tornado output. And it went in cycles. It produced tornadoes in the eastern Gulf Coast region the first day, in the southern Appalachians and Carolinas region the second, and then in Virginia, Maryland area, southern Pennsylvania on the third day. And we had actually a pretty rare for a remnant hurricane, a moderate risk out for that third day, because there was so much instability and still plenty of shear left over. So these things can be serious business. Most tropical cyclones don't produce like Harvey, which was produced 52, or like Ivan did in 2004. And I can show some graphs on that later. But we issue the watches, the local forecast office issues the warnings and collects the reports, and then we aggregate that on our homepage and display it after the fact.
And Roger, you're talking about, the specific storms, Harvey. I know for a lot of folks who are probably listening or watching tonight from the Carolinas, Hurricane Nate produced several tornadoes in western North Carolina and the upstate of South Carolina. Talk to us about, you were saying a little bit how these are not characteristics of tornadoes we would see in any given spring or fall setup. So what are the differences? What different scenarios do we see that hurricanes or tropical storms produce with tornadoes than what we'd see on an average severe weather day out in the Midwest?
The biggest difference is that in a tropical cyclone, you tend not to have influences from really cold conditions aloft. You don't tend to have what we call steep lapse rates or big changes in temperature with height. It's a very moist environment. As you know, with a hurricane or a tropical storm, there's a lot of water there. And so the instability is actually the biggest question, our biggest challenge in forecasting tornadoes and tropical cyclones. Another big difference is that they tend to move, since they occur north through southeast of the storm, they tend to move in a different direction. A lot of mid-latitude tornadoes move from west to east or southwest to northeast. Tropical tornadoes tend to move out of the south or southeast or east, sometimes even northeast. So it's a different direction. For folks used to looking in one direction for a tornado and then to have one come from a different direction is a little bit jarring. They tend to be rain wrapped. They tend to be hard to see. They don't last as long. On average, they're not as intense, but if it hits your house or your mobile home or your business, it's intense enough. And so they're still a pretty substantial hazard, even though they're not as big or long lasting as the mid-latitude large supercell tornadoes that we tend to get in Oklahoma or Alabama or in the Carolinas during other times of the year.
And Roger, is there a specific area of a landfalling system? Is it to the north or the south, or a lot of viewers are wanting to know, is there a specific area they need to pay attention to when tropical systems move in?
Oh yeah, you bet. And if you'll let me, if I can do a screen share here, I'll show you some that along with some other aspects of tropical cyclone tornadoes. I don't want to PowerPoint you guys to death because I know how that can go. But what I'll do here is I'll try to display just a few slides on where tropical tornadoes tend to occur. This is not one. This is actually the screen background that I use. It's a tornado I photographed in Oklahoma back in October of 1998 when I was chasing. That's a placeholder. So what I'll do is I'll put on the screen, hopefully you see that map. That's the southern and eastern United States, and that is a map of tropical cyclone-produced tornadoes in 1995 through 2017. And the reason we start this graph or start this map in 1995 is because that was when we had the NEXRAD radars fully installed up and down the Gulf and East Coast. So our climatology of tropical tornadoes starts then. Before that, verification and reporting was a lot more erratic and inconsistent, but the process and the procedures for reporting tornadoes has been pretty constant since 1995 with tropical cyclones. So that's why we start our database then. We've had over 1,400 tropical tornadoes since 1995. That was an active season. The dots on the screen represent EF0 to EF1 tornadoes in red, EF2 to EF3 in blue. We haven't had any tropical tornadoes stronger than that in terms of damage on the record since 1995. There have only been 2 known F4s or EF4s in history. One of them was in Louisiana, I believe it was with Agnes, and the other came on shore at night in Galveston with Hurricane Carla. So it's really rare. Doesn't mean it can't happen. So here's a distribution of tropical tornadoes, and you can see that they're most common within about 200 miles of the coast. So Florida gets a lot of them because everywhere is within 200 miles of the coast in Florida. And they occur from obviously Texas all the way up to the Mid-Atlantic region. There are outliers with remnant inland systems, 2 or 3 days inland across Illinois, Indiana, Pennsylvania, even Oklahoma. Those mostly are from Tropical Storm Erin in 2007, which essentially spun up again on top of us in what Marshall Shepard calls the brown ocean effect. I was part of a paper with John Monteverdi of San Francisco State, wrote a formal paper on that event. A very anomalous event, but nonetheless, it was still a tropical system at that time. It re-intensified inland. And of course, you guys in the Carolinas, you're looking at a lot of tropical tornadoes over the period. Essentially, your vulnerability to hurricanes and tropical storms pretty much matches your vulnerability to tornadoes produced by them. So that explains this map. And then if we go to the distribution by year, you can see it varies a lot. From none in 2009 to over 300 in 2004 when we had really active season with storms such as Ivan and Jeanne and a few others. And last year we actually had a relative spike. It had been quiet for a long time. The infamous lack of landfalling major hurricanes in the United States since 2005 also gave us not that many tornadoes. But last year we had a few, and we had tornadoes with them. It doesn't march in lockstep with the number of hurricanes, but it's a close graph in that regard, and it varies a lot. So you can't let your guard down. Some years are very inactive, some years are active, just like with tropical storms and cyclones in total.
Hey, Roger, I got a quick question for you.
Sure.
I wanted to go back to that distribution map real quick and ask you, for the Carolinas, do you think that topography has something to do with the majority of these tornadoes, especially South Carolina? There seems to be a lot of like the stronger tornado activity. Do you think that the onshore flow heading upslope has something to do with this kind of rotation?
That's an excellent question. And we think the influence is indirect. In other words, a lot of the time in the Carolinas, as you know, you get these what we call backdoor fronts or cold fronts that back in. You get cooler air in the mountains and on the Piedmont, And those fronts tend to linger for several days. Sometimes hurricanes and tropical storms move up and interact with those fronts. One thing we found both in the Carolinas and all across tropical storm-prone areas and hurricane-prone areas is that fronts and other boundaries, even if they've weakened and they're just remnant boundaries, tend to either concentrate or limit tornado activity, depending on how cold the air is on one side of them. I did an analysis with Al Patrica, who's now the Science and Operations Officer in Pleasant Hill, several years back, on historical events that showed that fronts can actually either concentrate tornadoes or limit where they occur. And one of the infamous examples in the Carolinas, of course, is Fran, where tornadoes occurred east of the front in the tropical air, but as soon as the supercells in the tropical cyclone moved across that front into the cold air, the tornado production stopped just like that because it was too cold and too stable on the west side of that front. And that is indirectly a topographic effect because the topography there influences the position of the front. So it's not a direct effect, it's an indirect one, but it still does affect the tornado threat in some ways.
Interesting. Yeah, I've always told folks it's not the onshore winds that are going to knock the power in the trees down. It's going to be the wraparound flow that usually pulls those down. It seems to be the case here. But yeah, that's fascinating. That's a really interesting map.
Well, in this case, too, tornadic supercells tend to occur in the onshore flow, the overwhelming majority of the time. And so when you have that onshore flow, especially when it's from the south, southeast, or east, that is when your tornado threat is maximized. And in fact, what I can do is I can skip forward here to show you where inside the tropical cyclone envelope tornadoes tend to occur the most. So what I'll do is I'll show you a graph. I'll just call that up here. There we go. What you see is you see four what look like radar displays or polar plots. And I'll just step through these really quick. These red dots are tornadoes in tropical cyclones. And in panel A, the upper left, that is all tropical cyclones for our period since 1995. And so the red dots are tornadoes, and they're concentrated, the reports are concentrated from the center outward. The numbers on the rings are radiuses in kilometers. And so I want to make sure that you understand those are kilometers and not miles. We have to make them in kilometers for research purposes, international presentations, and so forth. So you can see that the distribution is, with respect to north, south, east, and west, is overwhelmingly from the north of center around through northeast, east, and southeast. That's in the onshore flow region. Panel B switches over to just hurricanes. And so you can see with hurricanes, the tornado reports tend to be northwest through east of center. And so I'm going to actually throw a question back to you in our audience. Can anybody guess why there would be so few tornadoes in hurricanes south and southeast of center? So tornado reports in hurricanes south and southeast of center compared to tropical storms in panel C, or especially depressions and unclassified lows in panel D. Why is it, do you think, there would be so many more tornadoes in tropical storms and depressions southeast of center compared to hurricanes? Does anybody have a good guess? I'm putting you panelists on the spot here.
I'll take a kind of a guess here that with the northeast quadrant being strong in hurricanes, I imagine going from east to west against the Coriolis effect with your upper air entrainment, you end up with dry air entrainment on the western quadrants of the system a lot of times, whereas your moisture feed, your monsoonal feed is coming up from the south and from the east. That would be sort of my guess.
We have any other guesses? Has anybody from the audience chimed in to offer one?
Nope.
Well, this one is pretty easy to overthink, especially for for smart folks like you guys. And the answer is actually brutally simple. In hurricanes in the United States, the southeast quadrant is typically over water while there's still hurricanes. So we don't get tornado reports there. That's really what it amounts to. It's not even necessarily meteorological in nature. Those few times when we've had mature hurricanes, still classified as such, with that part of the system over land, like sometimes we get in Florida, those southeast quadrants do produce tornadoes. There's just typically not land underneath them. So this offers a lesson in how things that don't even have to do with meteorology necessarily will influence tornado reports, and especially tornadoes reported in hurricanes, because we're not getting reports over the Gulf or over the Atlantic, where that sector of the storm typically goes. As the storm weakens and moves inland, of course, it becomes a tropical storm, tropical depression, and then maybe a remnant low. Then, of course, the whole thing is inland. We get reports from anywhere within the circulation. So that's one of the interesting little quirks of tropical tornado activity. So I'll go ahead and turn off the screen sharing here and throw it back to you guys.
That's fascinating. That's something definitely overthinking of what you just brought up there. Ashley, I wanted to bring a question to you because you're our emergency manager, and Roger, I'd love for you to chime in as well. You know, Ashley, especially with you living in the Texas area, you know, you guys are also prone to hurricanes. How do you effectively communicate? Not only is there a hurricane threat for our area, but also warn your emergency folks and your residents in your area. There could also be tornadoes associated with this.
That's a really good question. And luckily, I am farther inland than kind of Houston area and all of that. And I haven't really had the opportunity to have that threat since Harvey and the tornado risk was closer to the coast, farther south. But I know that some people are talking about the issue that we're telling people to shelter for tornadoes, but there's floodwaters. So there is some safety jargon that's going on that's conflicting. So what I want to do with my community is make sure to tell them that there are multiple risks associated with every storm system. And I try to tell people to take the best action to reduce the largest risk possible. And that's a huge challenge. And I'd love to hear what he would have to say or anybody else would have to say with that, because I think that's a question we're all asking after Harvey.
Well, I'll be glad to discuss that too. And of course, Ashley, your challenges as an emergency manager are so intense in tropical cyclones, because you have to deal with so much more than just the tornado threat. And like you said, the tornado threat, as much as I like tornado studies, it's secondary a lot of the time. On the coast, it's secondary to storm surge and wind. Inland, it may be, as especially in Harvey's case, secondary to flooding. And Jeff Evans and others, Jeff is the meteorologist in charge at the Houston office. He delivers a really nice talk on the quandary they face and exactly what you're talking about, where they're issuing tornado warnings, and the canned statements in the tornado warning say, see shelter underground or in an interior room on the lowest level. But that won't work if the lowest level's underwater and you're on your roof because there's your house is flooded, and then you can see a tornado. Several people did in that area. So what Jeff and others are advocating, and rightly so, is that we, as both a weather service and as a preparedness community, need to rethink situations like that. And how do we triage or prioritize safety according to the intensity of the hazard, just like Ashley said. And there's no easy solution, but we're starting to work towards some.
Yeah, definitely. And I would say, too, just communicating that threat to people. It wasn't necessarily tropical, but we had a tornado a few months ago that it kind of occurred, not out of nowhere, but a marginal risk, and it wasn't really expected. So we didn't have watches and it wasn't forecasted or anything. So people just aren't really prepared for these kinds of tornadoes. When you say tornado, they think, you know, the wedge out in Oklahoma. They think, oh, I'm going to have watches far in advance and I'm going to get warnings on it. But these warnings or these tornadoes pop up really quick, and they don't always have that kind of warning too. So trying to get my community to understand that tornadoes can happen, especially the small ones, without warning sometimes, is hard for them to understand too.
Yeah, and that's exactly right. And that touches also on some questions that Shay and Scotty asked earlier about SPC operations, and that our tornado watches are intended to cover aerial tornado threats. And by aerial, I mean over areas, not an isolated rogue event that pops up and it's gone within a very short amount of time. And that's a predictability thing. And so tornadoes, there will always be the threat, no matter how good technology gets, no matter how scientifically educated we all get. Because the atmosphere is chaotic, because things occur on scales we often can't measure, there will always be a threat of a tornado hitting that's not in a watch or not in a warning. And so folks need to be prepared for that possibility with any sudden severe thunderstorm, and be ready to act as soon as a warning is issued, but also stay aware, keep an eye to the sky, and don't live in a bubble with respect to the weather.
Definitely. That's what I'm trying to teach my community now. I believe Shay has a question.
Yes, one more from me, Roger, and this has to do with the eye. So a lot of times when storms are making landfall, folks think, oh, the inside the eye is calm, and it generally is. It's been conveyed that way for so many years now that a lot of folks probably think that being in the eye is safe for a period of time. I want to show this feature. Let me know when you can see this on screen. And what we're looking at is the eye of Hurricane Isabel. And if I push play on that, you can see that the eye wall has a bunch of swirls around it. These swirls are called mesovortices within the inner eye wall, which shows that this eye probably is not as calm as you may think it is. And another video here this is from NASA Scientific Visualization, showing the eye wall mesovortices. And I just wanted to ask you your opinion. You know, when it comes to these kind of storms, do you think that a greater concentration of stronger tornadoes may come from these along that onshore flow, or do you think that this is a regularly occurring thing with some of the stronger hurricanes?
Well, there's a spectrum of what we call vortices in the atmosphere. It ranges from large mid-latitude cyclones and really giant hurricanes like Allen or Carla or Gilbert or Mitch that span 1,000 miles in terms of their influence, all the way down to the little dust devil on the street corner or out in the Arizona desert. And so sometimes it's tough to classify and put these things in boxes and say, this absolutely is a tornado or this absolutely is not. In fact, on my personal website, if you ever want to visit for severe weather photography, it's Skypix, SKYPIX.ws. I have an example of a mesocyclone from a supercell that has intermittent little dust spin-ups in it. What's a tornado? What's not? When does it start? When does it stop? There's no hard, fast rule for that. And so there's a lot of times it's difficult to classify these vortices and say for sure. That's background for what I'll say next. When we have these eye wall mesovortices, and they're well documented now with these great satellite images, such as what you showed, mobile radar, such as Josh Werman and his Dow group have documented those in several hurricanes, such as Harvey. Ted Fujita documented them with the damage survey for Hurricane Andrew in 1992, which I was privileged to help him out with just a bit. I was there for Hurricane Andrew. I was in the eye wall of Hurricane Andrew. It was a really intense and interesting event that had mesovortices like that embedded in it. Ted Fujita, and I totally have concurred with him on this ever since. I had that one conversation with him while he surveyed. He was very careful not to call these things tornadoes. And the reason why was because we couldn't establish continuity from, let's say, the vortices that you observe on satellite above ground to anything on the ground. We couldn't observe continuity from the damage, from the swirls of damage in the eye wall to anything that was actually in the column of convection inside the eye wall itself. A tornado, by definition, has to be continuous from the ground up through the convective cloud. It has to connect the cloud and the ground. It cannot be discontinuous, or it's not a tornado. That's why we don't call things like gustnadoes, the little swirls that show up on gust fronts, tornadoes or dust devils, because there's no thunderstorm above them. In the case of these mini swirls, we don't call them tornadoes. Sometimes they may be misclassified as such based on the rotational damage characteristic. But if we don't have a continuity between the ground and the cloud, we don't call these things tornadoes in a scientific sense. Now, that's different than an impact. If one of these things hits your house, these little shear vortices that are occurring around the inside of the eye wall and does exceptional damage, like in Hurricane Andrew, well, you don't care if it's called a tornado or not. It's still super intense wind damage inside what's already a very dangerous area. And so folks need to understand that whether it's called a tornado or not, it's similar to whether a huge flood event has a name attached to it or not. It's going to cause the same impact regardless. And so even though we may not necessarily have this thing called a tornado in parts of the eye wall, you will experience intense periods of wind on top of the already damaging wind that's there. The eye wall is a very unfriendly place for folks to be.
Thank you very much for the answer. I think Scotty was muted, but I appreciate you addressing that, because that's probably the most fascinating part of hurricanes to me, is just that inner eye wall, what's going on right there. And if we get one of our sensors in there, what kind of recordings can we get? So anyways, back to you, Scotty.
Thank you, Shay. Yeah, you would know by now, I'd know how to unmute my microphone when I wanted to talk, but not the case. I know we're a little bit past 9 o'clock here on the East Coast. Roger, I have one more question for you, and then we can kind of wrap up if no one else has any other questions. But I was able to set in on a presentation that you did on this particular topic, and one thing that you really talked about and kind of had some data to back it up is these tropical cyclones or these tropical tornadoes produced by these cyclones are more prevalent in the day than at night. Is that correct?
That's exactly right. And the reason is really straightforward. In the daytime, we have more dry slots, more areas of heating, more cloud breaks that allow the sunshine to come through. And so what that does is it allows more instability to happen in the tropical cyclone. All that moisture that I talked about from the surface all the way up to the upper levels and all the cloud cover tends to limit how unstable the atmosphere can get. That's one reason we get more tornadoes out near the edge of the tropical cyclone than we do in the middle or near the center. Because in the middle and center parts, you have that dense overcast, what we call a central dense overcast. That limits how much the surface can heat and destabilize. But as you get out toward the edge, we tend to have more sunshine, tend to have more instability. And all it takes, as moist as it is out there, is for just a few degrees of heating, and the instability increases tremendously in such a moist environment. And so that's why in the daytime, there are more tornadoes than at night with hurricanes. And they also tend to occur out near the edge more often than in the middle. Another factor at play is the shear. Believe it or not, even though the shear even though the winds, and let me back that up, even though that winds are stronger often near the center, shear is stronger out near the edge. That's favorable for tornadoes. And that's because the difference in wind between the surface and just a mile or so above is a lot greater out near the edge than it is in the middle. The winds tend to be more uniform in the center part, and there tends to be more shear out near the edge, more change in winds with height. So there's more instability, there's more shear. That gives us more tornadoes out in the middle and outer parts of the tropical cyclone, and more tornadoes during the daytime as well. But I'll remind you guys again, we had an F4 in Hurricane Carla in Galveston after midnight. So that can happen at any time of day or night. And so if you're dealing with the edge part of a tropical cyclone and you're far away from the center and it's 2 a.m., don't let your guard down, because you can still get a tornado from that.
That's some good information. Well, Roger, I know you're at work, so we don't want to keep you too much longer. James, I mean, Jared, Shay, Ashley, you guys have any other questions before we finish?
I just I've got my screen up real quick. This is a screen capture I took during Irma. During Irma, we took quite a hit from tornadoes. We had a couple get warned and many of them not. It goes to that, that probability of detection is very low when you're dealing with these low top supercell tropical tornadoes. And so this was just remarkable to me. This is just it was the supercells just laying in wait, just ready to rotate onshore. You can see, and this is and again, we were 300, 400 miles away from the center at that point. And so just kind of underscoring all of your points tonight, Roger. A lot of little notches in the storm relative velocity, and this came on shore, and several people got some brief short-lived damage, but they're still talking about it today. So some really some fascinating information tonight, and some things that made sense, and it was nice to hear it make sense. So very good.
Yeah, we had the largest water spout I think I've ever seen, rain-wrapped water spout. Just usually you get the condensation wrap, right? But this was like full wrap, like big, stuff you'd see in Pompano Beach, right? Just coming onshore instead of going offshore, coming onshore. It's pretty interesting stuff.
Well, that graphic you put up was actually a very, very good illustration of how velocity signatures and reflectivity signatures look on radar with tornadic supercells. And we don't know how many of those are producing tornadoes over water, but we know that a lot of them keep producing as they move onshore. And so as you're looking offshore, south of Charleston, northeast of Brunswick, east of Savannah there, you see several what we call couplets on the right, which are red close to green, mesocyclones. But notice as you compare those locations to areas on the left, it looks like a big mess. Those things don't look like Midwestern supercells. They're producing tornadoes embedded inside messy clusters. They're small, they're hard to detect. In this case, the radar at Charleston did a good job of picking up on some of those, but others might occur literally under the radar, too shallow for the radar to see. Others might be too far away for the beam to detect well because they're so small. So the percentage of tornadoes that occur in warnings in a hurricane is lower than it is for other situations in the rest of the country because they're so messy and hard to detect. What that does is it emphasizes what Ashley was talking about in terms of the importance of being prepared to be hit, even if you're on the outskirts of these things, being prepared for the possibility of a tornado if there's a thunderstorm headed your way, even if there's not necessarily a warning out. Have a preparedness plan in place and be ready to take shelter on just a few seconds' notice if you start to see and hear the crashing noises, the sudden rush of wind, the signs that a tornado may be hitting. These things are very difficult to successfully warn on. And I'm actually very impressed and amazed that we do catch as many as we do as an agency. But they are very, very short-lived. They come and go. They're very sudden. And that presents a different threat in and of itself. And in fact, if you can let me do one more screen share.
You've got it.
Just one more. What I'll do here is share one slide from dual polarization radar. This was actually with an event there in the Carolinas, northwest of Swan Quarter in North Carolina, with a couple of years back. This is more than a couple of years, August 2011. And so in the upper left, you see the radar reflectivity, what we usually see on TV. It just looks like a hopeless mess. Good luck issuing a warning on that, especially for a small, quick-hitting event like a tornado. If you look on the upper right, that's the velocity presentation. Well, that'll definitely get your attention. There's the radar's to the southwest, and so you're seeing some strong inbounds or blues next to some weaker colors or red. So that gets your attention, but it may not necessarily trigger a warning by itself. On the lower left is a seldom used but important meteorological product called spectrum width. Well, that gets your attention because that's a measure of turbulence or how much change there is, so to speak, inside these the radar beam. Well, tornadoes will definitely do that, as will supercells. On the lower right, the newer dual polarization technology is what we call correlation coefficient or cross correlation coefficient. That actually is a measure of the difference between the returns from the horizontal beam and the vertical beam that the radar is sending out. Tornado debris tends to create a really loud signature of correlation coefficient because the correlation is low between horizontal and vertical. There's a big difference between small raindrops, dense rain like we get in these tropical systems, or even big raindrops, but it tends to be very uniform. All those red colors around the signature. But debris, whether it's grass, plant material, as probably was true here, or even pieces of houses or other things, when it's lofted, it shows up very, very well in a tropical cyclone. Even better than it does in mid-latitudes, because in mid-latitudes supercells, we have a lot of noise from other things such as hail and dust. Well, that's not the case in tropical cyclones. We pick up these tornadoes very, very well, not always. Sometimes they're too distant or small, but a lot of the time they show up this well. And while these things don't show up until the tornado is already in progress, at least it tells us, uh-oh, there's something out there. We can still alert communities downstream from this. That this supercell is tornadic and it can be producing something. And this is really a great testament to the dual polarization upgrade that we've had to our radars and the capability that we have. A very useful tool and one that we didn't have just a few years ago. There's a cross section through that, and essentially what this is a vertical slice, panel A, through that same embedded cluster, nasty looking supercell. And you can see how it's tilted with height. A is to the west, the right side of the panel is to the east. And so you can actually infer what looks like a plume or a vertical tilt to the debris that's being produced by that tornado, even as blocky as the data is. Well, that was real. That was palms or grass, marsh grass, plant material, pieces of trees, pine needles getting lofted into the air and returning a much different and louder profile than what we see with just ordinary tropical rain. And so I'll close with that promising thing in terms of being able to not only warn but also verify that these tornadoes are happening, especially in remote areas like those marshes around Albemarle Sound and other places.
It's amazing what technology can do to this day, and what is in the future is just amazing as well. So, Roger, a great presentation tonight. Thank you so much for coming on. Some great information. If our followers and viewers and listeners would like to follow your severe weather pictures I know you were talking about, and maybe interact with you on social media, how can they do that?
Well, the best way is I have a Twitter account. It's at SkyPix Weather, which is pretty long, but it's SKYPIX Weather. And so that's my Twitter handle, and you can find me there. And I post a lot of links to science and weather, and of course I'm a sports fan, Boomer Sooner, and so I post a lot of links about that stuff as well. So it's just a personal Twitter account, but obviously being a weather fanatic, I post a lot of stuff there, links to SkyPix photography and links to hazardous weather posts of all kinds, as well as just science in general. So if you're interested in that kind of thing, you're certainly welcome to follow me there. And you can email me if you have more questions that you didn't get to ask tonight. My work email is probably best, roger.edwards@noaa.gov, and you can ask me questions about tropical tornadoes, SPC, anything severe weather related.
Well, Roger, we certainly appreciate that, and we thank you for taking some time out of your work schedule to join us tonight here on the Carolina Weather Group, and we'd love to have you some other time down the road.
Well, good to be here, gentlemen and lady, and thanks very much for having me aboard. It was an honor.
You're welcome. Well, we're going to end the show, so if you want to stick around for just a few minutes so we can tell you about off air feel free to. But if you've got to run, we totally understand that. Looking at our schedule for next week, we're going to be talking with Dr. Janine Kreitner as we talk about volcanoes. We know volcanoes have been in the news here recently, especially over the weekend with that lava bomb that hit that boat in Hawaii. So next week, we're going to be talking all about volcanoes and also how they can affect the weather. So Janine Kreitner will be with us next week. And then looking into August, we almost have a full schedule. August 1st is still open, but August 8th, we're going to be talking with Matthew Macharney. I don't know. Ashley, you may have to correct me on that pronunciation of the last name, but he's going to be talking about volunteers during flood events. And then we're going to be talking about deratios and MCS systems with Russ Shoemaker from Colorado State. And then we're going to be kind of going into a coastal flow as we talk to Mark Willis with Surfline. And then My Coast. It's a new company that's starting out documenting coastal flooding and things like that. Chris Ray and Wesley Shaw will be joining us on the 29th of August to talk about that. So that's a look at the schedule for the next few days. As always, if you have any suggestions or ideas that you would like for us to do on the Carolina Weather Group, please feel free to contact us, and we will do our best to get those folks on the show. So for everyone here at the Carolina Weather Group, we hope you have a great weekend. Stay cool out there. And until then, we'll see you back here next Wednesday night for our next show of the Carolina Weather Group. Have a great weekend, everyone.